This video is going to give you some reminders and refreshers if you get stuck and don't remember what we talked about in class regarding factoring when the A value is 1. So these are not your actual notes. The ones we took in class are the actual notes, but if you need another reminder of what to do or what the signs are about, then this is the video to watch and review it. Okay, so I'm going to work out some examples, and with each example I'm going to talk about the signs and the importance of the jobs of the signs, because that's something that you've got to figure out as well as the numbers. So for the first example, we have x squared plus 3x minus 28, okay, and the back sign has two jobs. The first of its jobs means that you're going to have different signs. If it's a minus sign, it means you have different signs, or opposite signs, one plus and one minus. The other job of the minus sign in the back tells you to subtract to get the middle. So once we try to get the two numbers that we need, we have to be able to subtract them to get that b value in the middle, or it won't work for us. The job of the sign in the front, okay, depends on what kind of signs you have. Because we have different signs, that means one number has to go with the plus and one number has to go with the minus. So the sign in the front tells you that the big number goes with the plus. Okay, and remember in class I said that whoever is the boss, the big number is the boss, it goes with that sign. So the boss has to go with the positive sign. Okay, when we're factoring, we break them up into two binomials, and x squared is made by x and x. Okay, and then we talked about the minus sign in the back means different signs, so that means you need a plus and a minus, and it doesn't matter what order you put them in. It does matter where the placement of the numbers go, though. All right, so to find the two numbers, we have to multiply to get 28. And then we've got to subtract to get 3. Okay, so you always multiply to get your constant, and then either add or subtract to get to the b value in the middle. Right? So if you think about your factors of 28, the numbers that make 28 are 1 and 28, 2 and 14, and 4 and 7. There are no other combinations of numbers that will multiply to make 28. So from those factors, we need to figure out which two will subtract to make 3. Well, if you look at the two numbers, 7 and 4 are going to make 3 when you subtract them. Okay, so then we got to figure out who's going to go where. Because the boss is the bigger number, the plus sign has to have the bigger number. So 7 is the boss in the bigger number, so 7 goes behind the plus, 4 goes behind the minus. Now you can always check yourself and see if you have the right answer. If you take the constants in your binomials, the positive 7 and the minus 4, positive 7 minus 4 gives us a positive 3. That should always be that b value in your trinomial. If it doesn't work when you check it back, then that means either your signs are wrong and or your numbers are wrong. So you need to try something else and see if you can come up with better combinations. All right, so let's look at another example. Okay, if I have x squared minus 20x plus 100, again, the sign in the back has two important jobs. When it's a plus sign in the back, it means you're going to have the same sign, so either two pluses or two minuses. And then if it's a plus in the back, it means you're going to add to get the middle. Now, the sign in the front only tells us one thing. It tells us what two signs we need, because we need two of the same thing. So this sign in the front tells us both are minus signs. Okay, so when we go to do our two binomials, we're going to have x minus and x minus. Okay, and that's how those signs come about. Now, we've got to multiply to get 100, and we've got to add to get 20. Right, so there's a lot of factors that make 100. So let's come off to the side. Some of you may be able to come up with them in your head very quickly. Others of you may need to run the list before you can actually find them. So we have 1 and 100, we have 2 and 50, we have 4 and 25, and we have 5 and 20. Nothing else makes 100. All right, so looking at those, oh, sorry, yes, there is, 10 and 10. So now that we look at all those factors, we need to figure out which ones will add to make 20. So when you look at 10 and 10, 10 plus 10 makes 20, so that means x minus 10, x minus 10. Those are your factors. Right? And if you do the quick check that I taught you, negative 10 minus 10 does make negative 20. So you know you've got the right numbers and you know you've got the right signs. All right, so let's go ahead and look at another one. I've got about 5 of these to show you because there's 5 different scenarios that could pop up. X squared plus 6x plus 8. Remember, the back sign has two jobs. It means if it's a plus, it means you have the same sign. If it's a plus, it also means you're going to add to get the middle. And once again, because the signs are the same, that front sign tells you both are going to be positive. So when you go to break up your binomials, you're going to have x plus and x plus. Okay, so now we want to multiply to get 8 and add to get 6. Well, there's not a whole lot of numbers that make 8. There's 1 and 8, and there's 2 and 4. So out of those combinations, 2 and 4 are the ones that make 6. It doesn't matter where you put them because they're behind the same signs. So you have x plus 2 and x plus 4. And again, to do your quick check, positive 2 plus 4 does make positive 6. So I know I've got my right numbers and signs. Okay, let's look at another one. If I have x squared minus 12x minus 64. Okay, so remember that a minus sign in the back, its first job tells you that you have different signs or opposite signs. And its second job tells you you're going to subtract to get the middle. And because you have different signs, you've got to figure out who the boss is. So if you come to the front, that minus sign in the front tells you that the big number goes with the minus because it's the boss. Okay, so when we go and break this up, we've got to figure out who will multiply to make 64 and subtract to make 12. Okay, so for 64, there's a couple of different factors we've got to consider. We have 1 and 64, we have 2 and 32, we have 4 and 16, we have 6 and 8. I think those are the last ones. Right, so if we have those factors, then we want to look and see who will subtract to make 12 and 4 and 16 do. Okay, out of 4 and 16, 16 is the boss. 16 has to go behind the minus sign, and that means 4 has to go behind the plus sign. And to do the quick check, positive 4 minus 16 is negative 12. So our numbers and our signs check out. All right, this last one doesn't happen very often, but when it does, you need to know what to do with it. Right, you see plus and plus, so that means that they have the same signs and they're both going to be plus signs. So you go to split up your binomials and you get your signs all straight and you go to figure out your numbers. Well, it's got to multiply to make 4 and add to make 2. Well, there's only 2 combinations of numbers that will multiply to make 4. So if you look at 1 and 4 and 2 and 2, none of them add to make 2. So when you get to this point and there's no numbers that you can break it up in, then this is not factorable. This is a prime answer because you can't do anything to x squared plus 2x plus 4. So you can either write the words prime or you can write not factorable. Depending on what the directions tell you, it may request that you write not factorable. Okay, but prime means the same thing. Okay, the other last 2 things that you have to be able to do in the last 2 examples that this video will show you is every type that we do, we solve by factoring. So now I'm going to show you how to solve by factoring in 2 examples that require you to use everything that we've done up until this point. Okay, so for the first one, you're going to notice that it's got an equal sign. That's why we're solving it, but it doesn't look like the trinomials we've been factoring yet because something's on the wrong side. So the very first thing you want to look for and have to do, if it's not already done, is put it in standard form. Okay, and remember, standard form has everything on one side. So because the 63 is on the wrong side, we need to subtract it over. That way we can have a trinomial on the left and everything will go the way we want it to. So x squared minus 2x minus 63 equals 0. And now we're ready to break apart and get our binomials the way we were doing before. Okay, so we are going to have x and x. This plus sign in the back tells us we're going to have different signs, so one's a plus, one's a minus. The minus sign in the front, remember, tells us that the bigger number goes with the minus. So we've got to multiply to get 63 and subtract to get 2. So there's 1 and 63, there's 3 and 21, and there's 7 and 9. Out of those combinations, 7 and 9 are the 2 that subtract to make 2. 9 is the bigger number, so that's the boss. 9 has to go behind the minus sign, 7 behind the plus. Before you go any further, do your quick check and see if you've got them in the right place because you don't want to mess your answer up from here on out. So positive 7 minus 9 is negative 2, so we're good. Okay, but we haven't solved anything yet. Remember, to solve them, you have to break them up into your little baby equations. Every factor has to be equal to 0, and then you solve it. Because these are one-step equations, I'm okay with you guys doing that in your head, so you can get in braces, the final answers you should have are negative 7 and positive 9. And again, it doesn't matter what order they're in, as long as you have both of those values. All right, so that's one of the solving types. Now the second one, okay, ties in something else that we've already done, but you have to remember what to do with it. It is in standard form, so that's not the issue. This time, if you look, we've been dealing with when A is 1. Well, if you look at it, A is not 1 in this one. So that means that you have a GCF sitting in here. You must always, always, always get those GCFs out of the problem first. Okay, so the GCF to this problem is 2. So we take 2 out, and that leaves us with x squared plus 12x plus 27 equals 0. And now our A value for that x squared is 1, so we can break apart the trinomial. Leave the 2 hanging around for a few minutes, and then we'll talk about what happens to him when we go to solve. Okay, but we need x plus and x plus, same signs, both pluses. You got to multiply to get 27 and add to make 12. So the numbers that make 27 are 1 and 27, 3 and 9. Okay, and obviously out of those two, 3 and 9 are the two that make 12. So the 3 and the 9. Now, when you go to do your solving, okay, this 2 has to go away. So right now, because it's 2 times some stuff, to make it go away, we divide by 2. And what we do on one side, we do on the other. So it looks like magic because it goes away and just kind of disappears, but it really didn't disappear, it divided away. So now you've got x plus 3 times x plus 9 equals 0. And we're right back to where we were with solving the baby equations. You've got x plus 3 equals 0 and x plus 9 equals 0. Okay, again, one-step equation, so I'm okay if you jump straight into your answers and come up with -3 and -9. Okay, so once again, these are all the examples of things that we did when A equals 1 and how to solve them and what to do, and the reminder of the signs and how important they are. And we're going to keep using this as we build on our factoring skills and go into other types.